for multiple reasons. One being, I like the strategy that we're going to use for this problem. I think it'll help you on multiple problems in the test. So let's check it out. They give me this equation, k equals 0.5 mv squared. They tell me that k is the kinetic energy, m is the mass, and v is the velocity. Now here comes the question part. It's saying a researcher also wants to find the kinetic energy of a second object with half of the mass but twice of the velocity of the first. What is the ratio of the kinetic energy of the second object to the kinetic energy of the first? Now here's the strategy. See how it never really gives me concrete numbers, any numbers to work with. All it's saying is the velocity doubles and the mass is half. So what I'm going to do is I'm going to make up the first scenario. So I'm going to, let's pretend as if the mass was 4 and the velocity was 2. And again, I just made up these numbers 4 and 2. There's no right or wrong answer here. You could have made it anything you wanted. Now, based on m being 4 and v being 2, let's calculate the kinetic energy. So that'll be 0.5 times 4 and then 2 squared. All I've done is replace the m with the 4 in the formula and the v with the 2. So 2 squared is 4. Then I have 4 times 0.5, and I'm just gonna, so 4 times 4 is 16, 16 times 0.5 is 8. So in the first scenario, based on these numbers that I made up, I got my kinetic energy to be 8. Now let's do what the problem is telling me. It's saying that let's cut the mass in half. It's saying second object with a half of the mass. So now my new mass will be 2. And it's saying the velocity is twice, so the velocity will be 4. And now let's calculate a new kinetic energy. So this will be k equals 0.5 times 2 times 4 squared. So 4 squared will be 16, so it'll be 16 times 2 times 0.5. So 16 times 2 is 32, and half of 32 is 16. So k will equal 16. Another way to look at that was 0.5 times 2 is 1, 1 times 16 is 16. So now my kinetic energy here is 16. So the final question now is saying, what is the ratio of the kinetic energy of the second object, which is 16, to the kinetic energy, I can't say kinetic energy of the first one, so it'll be 16 to 8. So that'll be my final answer, 16 to 8, and a ratio can be expressed as a fraction, so which is 16 divided by 8, meaning 2. 2 would be the final answer here. So the strategy here to keep in mind is if they give you just these vague terms like something's getting double, something's getting half, make up an original scenario and calculate it. If you understand this, cool. If not, I'm just going to make up a set of different numbers and I'll just show you how it works out no matter what I make it. So let's make M10 and I'll make V4 this time. So if that's the case, my kinetic energy, I'm not going to show all the work, v squared, 4 squared is 16, 16 times 10 is 160, 160 times 0.5 will be 80. So that's what the kinetic energy there will be. Now let's do the changes it was telling me to do. It's saying that m gets cut in half, so my new m will be 5, while the v gets doubled, so the new v will be 8. So 8 squared is 64, so that's 64, and then I'll have 64 times 5, and that's why I made the numbers a little bit easier over here. So it'll be 64 times 5, which is 320, and then half of that will be 160. So the kinetic energy, there will be 160. So again, final answer, the ratio of the second to the first, it'll be 160 to 80, which reduces down to 160 divided by 80, or just 2. Same exact thing. So no matter what numbers you make up in the first scenario, as long as you do the right steps for the second one, calculate it, you can figure this out. I love using this strategy. So if you see questions similar to this, make up some numbers, calculate whatever you need to, and then answer the final question based off of that.